Okay, in this video, we're going to show you how to construct a ventilator. A ventilator is a mechanism that helps you breathe if in fact you have pneumonia or you have the Wuhan virus and your lungs are constricted in some sort of fashion. If you would pan down here and show the my lovely assistant is pointing out the ventilator that we've made. This is what is called a negative pressure ventilator. That is different from a positive pressure ventilator. A positive pressure ventilator is what most of the hospitals are using, and they will knock you out with drugs and put a piece of plastic down your throat and then pressurize and to help you breathe. That is not something that can be done at home. A negative pressure ventilator, on the other hand, takes this chest box and uses it to apply pressure and a vacuum to the exterior of your torso to inflate the lungs and then deflate the lungs. It is something that can probably be done safely at home. Everything I'm showing you here is a last-ditch effort. When you cannot get admitted to an emergency room or they're out of ventilators, this system might save your life. If you go to openrecords.org/vent, there are more details that describe how this is put together. But I'm going to point out the main elements right now. Over here is the motor drive. Would you hand me the motor from the desk, please? This motor drive is from a child's toy. Just move the chair. This is from a child's toy, or a ride-on vehicle, and it's about an eighth of a. You can just walk up here. It's about an eighth of a horsepower. Here is an example of another one that I have salvaged. Is that in the frame?
I can't see it. It's black on black.
All right, can you see that?
Hold it up to your chest.
Okay, we're going to do this. This is an example of the motor drive. Here's the motor. There's the drive that normally drives the wheels on the little toy car. Back down here again. We needed an additional 5-to-1 reduction to get the amount of torque required and to get the respiration rate that we desired. This is a piece of PVC that has been screwed to, I believe that's 1 3/4 inches, has been screwed to the motor drive, and we took a piece of rubber from a bicycle tire and we used adhesive to give that extra friction. Here's a belt drive. This belt is made out of packing strap with more of that inner tube adhered to the inside of it to increase the friction. This drive wheel is actually the wheel from the toy. This is the shaft from the toy as well. So we get the 5-to-1 reduction here. If you can see this here with the spring, that is a belt tension adjuster that we found helps maintain consistent pressure on the belt as it turns. This shaft here drives the pump, drives the air pump that inflates the lungs or deflates the lungs. This was made from a think a mop handle. That was all we had. Since we're in lockdown, we can't source all the components that we would like. This box here encloses the pump. The pump is made from the white plastic dryer vent. It's about 4 inches in diameter. Many of them have been replaced by aluminum these days, but you can still get the white plastic dryer vent, and we use it as an accordion. We compress it, we bring it back to its size, we compress it again, bring it back. That's what this does. At the end of the accordion, we have this hose, which goes to the chest box. The chest box sits over the chest, just at the bottom of the rib cage, and down slightly below your waist. And that is what is the pressure. It's pressurized, and then a vacuum is drawn. It's pressurized, and then a vacuum is drawn. Now, what we have done is we have put a speed control, a breath control on top of this, so that the individual can adjust this to the breaths per minute that he or she is comfortable with. This also has the capability to turn off the pump so that the individual can cough, can eat, can spit, can take medication, and so forth. Let's see. Oh, this is the battery backup. Over here, this is the power supply that we use for most operation. Over here, you can see the electronic circuit, and this is as simple a circuit as I could make. There's no microprocessors involved. The schematic for this is on openrecords.org/vent. It uses a 555 timer and a high-power MOSFET to generate pulse width modulation. In simple speak, it makes it go fast, it makes it go slow. This little black box here is the relay that came from the kid's toy, and that's what turns the master power on and off. Okay, I think that's the major components. I would encourage you to go to openrecords.org/vent, V-E-N-T. I've got still photos and hints of how to assemble this. I would hope that I would hope that many people are able to make something similar to this. This is assembled completely from scrap. It was just things that we had, since we can't go buy anything. And I would further hope that possibly there's some entrepreneurs that will take this and improve on it and actually sell it. The cost of goods here is, if you had to buy all this stuff, is probably $50. Even if you have to buy the motors. This is very, very inexpensive. And it is simple as I could make it, and as safe as I can make it. It is a last-ditch effort, but if you have nothing else, it might save your life.